Let's explore the idea of a logarithm function. We'll start with this definition. In short, we get if y equals log base a of x, that occurs if and only if x equals a raised to the y. So for this particular function, we say log base a of, and that's what's inside the logarithm. So how does this work? If we have 4 to the second power equal to 16, then we can say we have log base 4 of 16 equals 2. And this occurs because 4 raised to the second power equals 16. Since we have 5 cubed is equal to 125, then log base 5 of 125 equals 3. When we write these equations like this is called exponential form, and when we write it like this, naturally it's called logarithmic form. Now you try, please. Convert this logarithmic equation into exponential form. When you're done, hit play again. So how'd you do? When you convert this, we take the base, which is 5, we raise the 0 up on its shoulders, and it equals what's inside. So 5, which is the base, raised to the 0, which was on the other side, is equal to the 1 that was inside this logarithm. Let's try another one. Now convert in the other way, from this exponential form to logarithmic form. Hit pause, then come back when you're done. So how'd you do? A little harder this way, right? I think the easiest thing to do is to remember that when it's in exponential form, this is the base, just the base of the logarithm, just as it's the base of this exponential piece right here. And so the base 5 is this base 5. The 5 lifts the negative 2 up on its shoulders. Here it is up on its shoulders, and it's equal to what is inside. So how'd you do? Hopefully, if you've been paying attention, you did well. Now let's take a look at domain and range. We're going to graph this function, so please draw a coordinate plane. Don't forget these labels, x and y's. Some of you tend to be lazy, so remember to label them, because when you get to your next course, the variables here are going to change, and we're even going to do applications this semester where we're no longer talking about x and y. For our function y equals log x, we get a curve that looks like this, and the intercept here is the point 1, 0. Don't forget to mark that, and always label those curves y equals log of x. Now let's take a look at the inverse. Here we have y equals log base a of x, which means this, in exponential form, the a lifts the y up on his shoulders and equals what's inside the logarithm. And so the a lifts the y on his shoulder equals x. Now when we do inverses, remember we switch the x and y. So that gives us this y equals a raised to the x. This is the inverse function of this function. So let's graph this guy first. The coordinate plane is already labeled. This is the curve y equals log base a of x, and it hits here at 1, 0. Now, when we get an inverse, remember we're switching the domain and range. So instead of 1, 0, we're going to have the point 0, 1 here, and then our exponential has this look to it. And we label it y equals a raised to the x. Now remember, domain and range switch when you have inverses, and so any point on here that you find the x and y, they switch places and they are then going to be over here. These, because they're inverses, they are reflected across this not very straight line y equals x. Now we do have different bases when we're talking about logarithms. So the first one is a common log. We typically write that as y equals log of x. And what's not written right here is that base of 10. This also can be written as y equals log, I was doing so well, base 10 of x, but we usually don't write this 10 because it's redundant. Log means base 10, so writing this is really a redundant thing. So this is the one we prefer. So put a star next to that one. That's the way I'd like you to write that. Now what happens with a natural logarithm? If by chance you have log base e of x, we really rewrite that as y equals the natural log of x. And sitting right here is that base e. Now please, this is not the ln of x. This is the natural log. So whenever you see ln, when you're working with logarithms, just call it natural log. Really weird, right? So here you just say y equals log of x, but here you have to say natural log. It's to differentiate between these two. The curves are very similar, but when you're coming up with that logarithm curve, when you have a base 10, it's sitting here. When you have a base e, it's coming out a little farther and then going up a little more quickly. Now other bases occur, you've already seen them in this show, and so, big show. So y equals log base 3 of x. And so other bases, that's the base. So you get a different number there. So for your notebook, please copy these examples from your textbook. They're located on these pages in your textbook. And then don't forget to write the summary as well. Work to keep a very clean notebook, please. And when you do that, I think that you're going to be a lot happier with what you're doing, because it's going to be a lot easier to find everything if you keep things highlighted and you keep everything in order.